Hello everyone, welcome back again. Today we'll be discussing about file imports, error handling, NumPy and Pandas as part of our bi-weekly lessons with KenteCode AI Academy. And we are on week 5 and 6. Imports, files and error handling. In Python, imports allows us to load and use code from other modules and packages. A module is a file containing Python code, and a package is a directory or a folder that contains other modules. Import lets us reuse code without rewriting it, organize code into logical units, and access Python's extensive library without third-party packages. When we want to import in Python, Python provides us 3 ways to import. We have import module, where we can import an entire module. An example is import math. And math is an existing module in Python. We can access the functions of variables in math using the dot notation. Here we have math.square root. Square root is a function that exists in math, and we have the results 4, which we are calculating on 16. So the square root of 16 is 4. We can also access the pi value from math, and that gives us the value of pi. We can also access cosine function in math. That gives us the value of cosine of 0, which is 1.0. We can also use from module import name, where we import specific items or functions or variables from a module. An example is from math, import square root, pi, and cos. We store our results in results variable. So square root of 16 gives us 4.0, because the square root function is accessed from math. The value of pi gives us the value of pi, and the cosine of 0 gives us the value of cosine of 0, which is 1.0 again. We have another method of importing. We have import module as an alias. An alias is another name we give to the module. We have import with a custom name. An example, import math as m. From collections, import counter as count. M is an alias for math, counter is an alias, count is an alias for counter. M.square root 16 gives us the value of square root, which is 4.0. Count counts the letters, the number of times a letter appears in a list. Error handling in Python. Error handling lets our program deal with unexpected situations like missing files or bad inputs without crashing. In Python, this is done using try except blocks. Basic structure. We have try statement and a code that might cause an error. We have an except some error and what to do if that error happens. An example we will look later on. Why do we have to handle errors? Handling errors helps us to catch errors early. Here are some few reasons. It prevents our program from stopping unexpectedly. It also allows us to show helpful messages to users as to why our users are seeing certain errors. And it also allows us developers to recover or clean up when something goes wrong in our code. An example, we have try statement declared and a code that might cause an error that exists here. We have accepting a value error, which is an error that would occur, and we print a statement that was not a valid number, and we also accept another error which might occur if our user inputs 0, where we print you can't divide by 0. So using try except block helps us handle different kinds of errors that would appear in our code. So value error, we know it comes when our user enters a string, and 0 division errors happens when our user enters a 0 in the number input. Now we are going to be discussing about NumPy and Pandas. NumPy, the reason NumPy was created is because when it comes to Python lists, they are very slow for numbers because it accepts data types. And an example is we have list 10, which is an integer, a string, a boolean, a dictionary, and a float. This various data types point to different aspects in the memory, and it costs memory and speed. When we want to work with millions of data and apply math on all of it at once, Python's lists are slow and can't handle the workload since they aren't built for analyzing or working with large or millions of data sets. Hence, NumPy was born because it is precisely used for numerical calculations in Python. When we want to create a NumPy array, we declare the import statement and NumPy library or NumPy module as NP. NP is an alias, a convention where other developers and the documentation recommends. We have our variable name scores underscore array, np.array, which is an array function that exists in NumPy, and our data which we pass in the array. Array has various attributes. We have the shape that tells us the dimension of the array, dtype that tells us the data type of the elements, and represents the number of dimensions, and size tells us the total number of elements. Array operations. NumPy supports element-wise operations, broadcasting many mathematical functions. Array operations include multiplication, addition, subtraction, exponentiation, division, floor division, etc. An example we have is A equals np.array, B equals np.array, where each value is passed into each variable separately. We print A, we have its array here, and we print B where we have its array. So when we want to pass an addition function on various array, we have A plus B, which adds the array in A and the array in B, where we have 11, 20, 20, 33. A times B gives us the multiplication for 10, 40, and 90. And A exponent 2 gives us 1, 4, and 9. This only occurs in NumPy array, whereas in list we cannot add two separate data sets. Pandas. Pandas is a powerful open source library for data analysis and manipulation in Python. NumPy focuses on fast numerical and arrays, like a supercharged calculator where we can calculate numbers very fast. Pandas wraps NumPy arrays with labels, giving us the power of a spreadsheet. It focuses on labeled data, table-like data built on top of NumPy, where rows and columns can identify names where they belong. Pandas has exactly two data structures. We have series, which is a single column of that spreadsheet. It's a one-dimensional labeled array that moves left to right, and a data frame, which is an entire spreadsheet which has a two-dimensional labeled table. When we want to create a Pandas series, we use the import statement where we import Pandas module as PD. PD is shorthand for Pandas, which is also found in the documentation. We have the series function that exists in Pandas, and we pass our data array of values into the series. So when we print the series, we see values like 0, 1, 2, 3, Alice, Bob, Carol, and Dave. So when it comes to Pandas, indexes are automatically assigned by Pandas, and the data type is also assigned, where we see the data type is string. However, the comparison between list and Pandas is greatly different, whereas in list we cannot identify the location of each value, the index, unless we use the square bracket notation. However, in Pandas we have the index that allows us to access each value. Pandas also allows us to create custom labels. So if we want to erase the default behavior of the series that gives us 0, 1, 2, 3, we can use the index keyword that can override the default behavior of using integers as row labels. Where we have our statements here, our series index become Alice, Bob, Carol, and Dave, and our values still remain 8, 8, 95, 70, and 100. We have our name, which is cost, which is the label for the whole series. We have the actual data, which is our NumPy array, which is this, the first value, and our data type for every value. We also have our row labels, that is shown as our index. In NumPy we can in Pandas we can access data using .loc or .ilog. .loc accepts string values, and .ilog, which is iLocation, integer location, accepts only integer values. So slogBob access the value of Bob, which is 95, and then silog1 access the value of Bob also, which is 95. So these are some methods that exist in Pandas. A data frame, which is the second type of data structures that Pandas allows us to use. A data frame is just multiple series sharing the same index, lined up side by side like columns in a spreadsheet. The shared index is the glue. Every column knows which row it belongs to because of it. When we remove the index, and then the data frame will fall apart. So we have several types of series. When we add them together, we get a data frame. It is the index that joins this data frame. So we have the series name, series age, series score, and the data frame creates all these together. So all three the same index, that's what holds them together. When we want to create a Pandas data frame, we import Pandas as PD, and the data frame keyword, the data frame function is used, where it accepts a dictionary. So the keys are the column names, and the value is the row names that will be given to each column. So when we declare the data as this, where we have one element as this, which represents column 0, another element as this represents column 1, and the score and its data represent columns 2, and pass and the boolean values represent column 3. So each key value pair represents one column, and this is shown as this. So we have the column axis, which is index given here, which is our index. We have our name column, we have our age column, and we have our score column, and this is our row axis. We have 0, 1, 2, 3, and where we have one row is one observation, and we have one column, which is one variable. We have other functions, other methods in data frame, where we have .column allows us to access the column's names, which will give us index name, age, and score. The row axis, which df.index, another method that allows us to access the index, and then the df.types allows us to access the data types of each column. We have df.shape that tells us the shape of our data frame. So 4,3 tells us it has 4 rows and 3 columns. So 4 rows and 3 columns. That brings us to our end of week 5 and week 6. Thank you.